This is topic 32, higher order derivatives. Now we're going to find the first and all the higher derivatives of function p of x. So we're going to start with the first derivative. Right, so we're just going to use the power rule like we've used in the past. So this would be negative 8 x cubed, let's see, plus 27x squared minus 10x, and then the derivative of 7 is 0. Okay, so now what they mean by higher derivatives is, for example, if I take the second derivative, the second derivative will just be the derivative of this function. So I'm going to just take the derivative of this, and that would be considered the second derivative. So negative 24x squared plus 54x minus 10. Alright? Now we're going to take the third derivative, and you guessed it, I'm going to take the derivative of the second derivative. So that's going to be negative 48x plus 54, and the derivative of negative 10 is 0. And then now I'm going to take the fourth derivative, and I'm going to use this notation right here. That would be the fourth derivative. So that would be negative 48, excuse me. And finally the fifth derivative would be the derivative of negative 48, which is 0. Okay, so that's all it means when it's asking you for the second derivative. Well, just take the derivative of the first derivative. Alright. In example 2, they're asking us to find the second derivative of 4 cosine x plus sine x. Alright, so the first thing we have to do is take the first derivative. There is no trickery here or anything, it's just a simple derivative right here. So the derivative of cosine is negative sine. So this would be negative 4 sine of x, and the derivative of sine is cosine, so plus cosine. Then if I take the second derivative, alright, I'm going to take the derivative of this. Derivative of sine is cosine, so this is going to stay as negative 4 cosine of x. And then this one right here is going to become negative sine. That's as simple as that. Okay. Now in example 3, they want us to find the first and second derivative of the graph above. So in this part, you're going to have to remember some information from your pre-calc class. Don't forget that if you look at it, I'm going to go ahead and say this is, if it starts at 0, that's going to be a sine function. So the formula that I can use for that would be this, where the A is the amplitude, right, and this over here would be the period. Well, the period is actually 2 pi over b. So we'll figure out what that is. All right, so now the amplitude, what that really means is the distance between here and here. So this would be the amplitude, this would be A. And if you look at it, if this is 2 right here, this must be 1. So the amplitude is 1. Okay, so I'm going to write here A is 1. And then the next part, to figure out the period, I'm going to have 2 pi over b. And where b is going to be, wait, hold on. I notice that the period here, the period is pi. That kind of looks like 2 pi, but this is actually 1 pi right here, and that's 2 pi right there. So the period is pi, and now I'm going to solve for b. All right, so if I solve for b, you can cross multiply here. That would give you 2 pi is equal to b pi or pi b, whatever you want to call it. And if I divide both sides by pi, b would be 2. Alright, so notice that now I'm going to go back to this function over here that I had. So again, b is 2. Alright, I'm going to write the original. This is the graph of this original function that I have here. So y is equal to a is 1, so I'm not even going to write that. Sine of 2x. So that's what we came up with. All right, so that's just the function. So to take the derivative of sine of 2x, we have to use the chain rule. So we have the derivative of the outer, which is cosine of 2x, plus the derivative of the inner, which is 2. So that's going to give me 2 cosine of 2x. Now to take the second derivative, I'm going to take the derivative of this. So I have the derivative of the outer, which the derivative of cosine is negative sine. So we have 2, well, I guess I can have negative 2, times the sine of 2x. Okay, times the derivative of the inner part, which is also 2. So this is going to be negative 4 sine of 2x. So that is that. Alright, let's carry on to the back. Now here we're going to learn a little bit of physics. Alright, so it says right here, if s of t is a position function of an object, so just to make sure we understand, a position function, if I plug in a time, it will tell me the location of that object at that specific time. Alright, so the rate of change to the position with respect to time is the velocity. So if I take the derivative of the position function, I get velocity. Alright, and the rate of change of velocity with respect to time is acceleration. So if I take the derivative of velocity, or the second derivative of position, I get acceleration. Okay, so let's take a look at a problem. Example 4 says, assume an object moving along the line is given by s of t, and you can read that rest of the equation for t in between 0 and 8, including 0 and 8. So we're going to find the beginning position. So to find the beginning position, all we're going to do is plug in 0. At t is equal to 0, what is my initial position? So all I have to do is plug in a 0 here, here, and here, and if I do, notice that I want to get a 0. So my beginning position is going to be at 0. Okay? Now the second part is asking me for the velocity at t is equal to 2. So the first thing I have to do is I have to figure out the velocity equation, which can be done by taking the derivative of the position. So again, velocity is equal to the derivative of the position function. So I'm going to take the derivative of this. So I have 9t squared minus 81t, and then plus 162. Okay. So that's the velocity. So now what it's asking me is asking me what is the velocity at t is equal to 2. Now to be precise, if we are talking about physics, this would be called the instantaneous velocity. So what is the instantaneous velocity at v is equal to 2? Alright, so at t is equal to 2, excuse me. So I'm going to plug in at 2 into this derivative, and that's going to give me the velocity at t is equal to 2. Okay? So that would be 9 times 2 squared minus 81 times 2 plus 162, which is 36. So that's that. Alright, and then finally C, I'm looking for the acceleration at that moment at t is equal to 2. So what is the acceleration? The acceleration is the second derivative of the position function, which is really the derivative of the velocity. Alright, so if I take the derivative of this, I'm going to get 18t minus 81. And now I'm just going to plug in a 2 into that equation to figure out what the acceleration is. So I'm going to plug in a 2 into the acceleration equation to figure out the instantaneous acceleration. I'm not sure that's a term, but I'm going to try to find out the acceleration, the rate of change at t is equal to 2, which in this case is 45. Okay, well, again, if you have any questions, make sure to talk to me tomorrow. I hope all of this makes sense, and well, I guess we'll see you next time.